Chapter 3 was all about quadratics. Chapter 4 is moving us from quadratics to polynomials. So here's the thing. A quadratic is a polynomial, but a polynomial is not always a quadratic. Okay. So a quadratic, the biggest term is x squared, right?
Yeah.
Okay. So a quadratic looks like this. Quadratic. Well, what's the prefix? Many, right? So quadratic is generally 3 terms, but it doesn't have to be 3 terms. What makes it a quadratic is this x squared, right? A polynomial is greater than or equal to 1 term.
If it's not, I forgot.
Okay.
I think it is from if it's not a BX, we consider it
0, correct? Yeah. So it could just have 1 term. It could have 2. It could have 10. All right. The only requirement with a polynomial is that all of the exponents on x are positive whole numbers.
Wait, but I've seen negative.
It's not a polynomial then.
Negative 8.
Okay, A's are coefficients. Your coefficients just have to be real numbers. Do you have a question, Liam?
Are there fractions exponents?
I was doing 8.
Whole numbers, they got to be whole. There are, and we will get to those, but they're not polynomials.
Okay,
So this is eliminating my i's as coefficients. I can't have any i's as coefficients. So no fractional exponents, no negative exponents. We just want positive whole number exponents. And then our coefficients, what's the coefficient?
A, B.
The A, the B, and the C, the number in front of the variables, right?
Wait, C is considered one? It's not.
So yes and no, it's a constant. So you just call it a constant, but it's still got to be a real number. So I want to include it in that. Because technically, that's the term. But anything to the 0 power is 1.
Yeah.
And we're going to talk about that today. All right, so we will be in this section, we will be adding, subtracting, and multiplying polynomials. But before we get to that, we need to talk about some properties of exponents because my exponents could get really big and I could be doing some different things with them. So before you can do all these operations with polynomials, you have to be able to do exponents. And you'll be surprised at what you know of these. There are 7 of them.
We do a lot of them in chemistry.
I hope you guys have at least seen them before. This is where, for whatever reason, of all the stuff in this chapter, and it gets sticky, this is one of the biggest hurdles for students because they always look at this and they go, oh, that's easy. That's easy. And individually they are easy, but when we put them all together, it starts to get a little bit harder to simplify. So let me run through. I think I'll run through and give you the 7 properties. We'll talk about each individual property, and then we'll put them together and see if you can simplify with them. All right, the first one, and you do not have to know the names of these. I don't care that you know the names. That's not important. I just care that you know what they do. All right, so the first one is called the product of powers. What's a power? Like an exponent. That's exactly right. All right, so product means I'm doing what?
Y.
I'm multiplying, right? So let's say I have x to the 3rd times x to the 2nd. Right. Okay, because here's what happens. And make a note, and for this to work, the basis, what's the base? X, right? The base is the number that has the exponent hooked to it. The bases must be the same here in order for this to work.
So before you do that, you need to probably divide one of the coefficients.
Do what?
Like, you need to take away the coefficient. So
Well, if they have a coefficient, it's just, if this was 2x to the 4th times 3x squared, then you multiply the coefficients. They're their own part. If you think about, this is really 2 times and 3 times. So it's really just a big, long multiplication problem. And since multiplication is commutative,
would that be 6x to the 6th?
yes. and you're adding those exponents. Make sure you add the exponents here. Y'all okay on that?
Yes.
All right. Property number 2. How many did I tell you there were? 7. If that is product of powers, quotient of powers follows. And this just makes sense if you think about it. What is the opposite of multiplication?
Dividing.
Division, right? So if I'm dividing, whenever I multiply with the same base, I do what? You add. So this time you subtract. You're exactly right. Again, be very careful. The bases must be the same. Then I subtract the exponents. And I keep saying same base because we're going to encounter some that'll have multiple bases there, and you'll only want the ones that have like bases. So here, 5 minus 2 would give me 3. Okay, subtract those exponents. Leave the base alone, okay? If I have something like, if this becomes 4 to the 5th over 4 to the, oh, I don't want to keep using the same thing. I'll say 4 to the 4th. You don't divide 4 and subtract the exponents. You leave the base alone. So it's 4, and what's 5 minus 4? 1. Okay, make sure you keep that base as is.
How?
Only when you're lying.
Like,
Yeah. Well, or when multiplying too.
Is it okay if we just keep it 4 instead of?
Yeah, sure. But Ava, to answer that question, if you look back at the multiply one,
Oh, the X.
oh, yeah, well, that's not really a good one. But if I had, if this was 2 to the 3rd times 2 to the 5th, it wouldn't be 4 to the 8th. You keep the base, yeah, it'd be 2. Come on. Then it's still X.
Like 4X over, 4X.
So there's-
4X over 4.
So yes, then you could simplify the 4 out. You just really have to remember that they're coefficients. So if it was 4x to the 5th over, what'd you say? 4 to the 4th. Because this is multiply and 4 divided by 4, they cancel out.
Without an X.
Yeah, you always leave it alone.
But, I know, but like, when multiplying. And that's where it's actually 6.
Right, right.
But without an X, so if it was 2 to 4.
You still leave it alone. It's still 2.
Yeah.
Where are you dividing? Well, one's the same thing here.
I'm saying like when that 4/5 to the 4/4, I mean over 4/5
Yeah.
over 4 to
Yeah.
the 4th, would that not be 1?
You can't, you leave the base alone.
There's not an X, so that's the difference.
Think about it like this. If it was 4 to the 5th, that's the same thing as 4 5 times, right? And on the bottom, that's 4 how many times? 1, 2, 3, 4. It leaves me 1 4 up top.
So, if there's an X, that's when you can like put it in there. But if there's no X, then you leave it alone.
What do you mean put it in there?
Like, okay,
I think you're thinking about this way too hard, but go ahead, ask me.
okay,
Give me an example of what you're talking about. Give me a comparative. Give me one of each.
okay. So, what if it's 2X to the 3rd times 2X to the 5th?
Okay?
Okay. And you would do 4X to the 8th.
Yes.
Okay, but if it was 2 to the 3rd, and then times 2 to the 5th, it would just be 2 to the 8th.
Yes.
That's what I mean, like. if
Okay,
it's
so
X
the
and
reason you
Y,
multiply these together, is that what you're asking? Why are we multiplying those together but not these?
Yes.
Okay, so think about it like this. What if I changed this problem to look like this? And I said 2 to the first times 2 to the first, right? That would be, and let me just rewrite it this way for you, since multiplication is commutative. 1 plus 1 is 2. You're still doing the same thing. We just know that 2 times 2 is 4. But the property's still there, if that makes
But like,
sense.
I'm just asking like, if there's an X. Cause like, it seems like when there's an X, you.
Okay, if there's a if there is an exponent on the coefficients, you'll want to add them. If there's no exponents on the coefficients, multiply them. Does that make better? Like, there's exponents here, but there's no exponents here.
Right, what about those, what if it was like 2 to the third times 3 to the fifth?
Those are not the same base, so you could not combine them without finding out what is 2 to the third, that's 8, what is 3 to the fifth, and then multiplying those things together. They have to have the same base to combine them.
So do you want to do that? Like, is it
Oh, yeah,
like
do you
I'm good with you
stall?
leaving right here.
You want
You'll get-
to stall?
You mean simplify? I mean, if you want, it's not wrong if you do.
You gonna ask us to our homework?
It'll ask you to simplify.
So,
But you can, that's simplified also, you can leave it like that.
so for the quotient of powers, what if you have like 6x to the second divided by 2x?
Would it be 3x to the third?
The coefficients get divided, so it's 3, and then 2 minus 1 is,
So what if it's like, so if it would be 6 to the second
Leave it.
divided by 2 to the second, three.
say it again?
If it were 6 to the second.
So just write it as it's not like perfect, write it as a fraction.
Divided by 2.
The only thing you could do there is if you knew that 6 squared is 36 over 2, which would be 18. Yeah.
So
Yeah.
if it's not like perfectly divisible, do you just leave it in the
Yeah,
fraction? Or do
yeah.
you mean like leave it, just like don't touch it? Like don't do anything? with it,
Right,
or
so
what?
if it was, I think you said something like
Like-
2x to the third over 5x. Well, I can't simplify 2/5. This is, see, I think this is where y'all are confused. If this is my term, 2x is not my base. My base is x, right? Now, if I look at this term, 2 is my base there. So this, I would just leave the 2/5, and then 3 minus 1 would be 2.
Okay,
Because it has an X
Right.
there. Okay, that's not hard enough.
What you got?
So would it ever be like 2x to the third over, 3, 4, 3, 4.
Like that?
No,
No,
like
this-
3, 4.
With no x,
Yeah.
just 3x going forward.
Like that?
Would it ever be that?
It could, but it can't be simplified from there.
No,
You're not, you just leave it.
All right, we're good. Next one.
Okay.
Wait, which one was it?
Number 3, that was probably the most questions I've ever had on quotient property before.
You know, after this last
Good job, guys, good
Yeah.
job.
We gotta make sure.
I'm
we know
being-
it.
That's right, that's good though, that's good. All right, the next one is negative exponent. And this, I probably should have done this right before, I don't like your book's order on this. But negative exponent. Anything that has a negative exponent,
Yeah. Yeah. We did that.
did you? What happens?
It goes backwards.
What goes backwards?
It's investment.
Literally, like, numbers go, instead of
that
going
way.
forwards, they go backwards.
What? Y'all are thinking scientific notation. That's not what I'm talking about here.
Well,
Not
we
the
use
same
that
thing.
scientific notation.
Okay, you do.
And them things turned into decimals, like you move your decimal point over one.
That's when you multiply by 10 to the negative 2. And you're moving it because you're dividing by 10 squared is what you're doing. And the reason that is what it is, and we will get to scientific notation so that hopefully you will understand why it is you're doing what you're doing and not just doing it because... when you have a negative exponent, you make it positive and you flip it. And by flip it, I mean make it into a fraction. So 1 over... x
I said
squared.
excellent.
Okay?
He taught us that. They just didn't.
I didn't.
I didn't.
Flip and make positive. Okay? If it's in the bottom,
So this is all.
so let's say it was 1 over x to the negative 3.
Then it'll become x to the third.
The exponent becomes positive and then it moves. So this would be x to the third.
So it's a positive receipt.
Yes.
The base is exponent.
Yes, but if it has a coefficient, that does not flip with it. So in other words, let's say I had 3x to the negative 1.
Yeah.
Yes, exactly, because the only thing this exponent is hooked to is the x. So the 3 is going to stay up top, but the x is going to move down. Now the reason I said I probably should have done this
Why didn't you
before
leave
question.
one in there?
What one? Well, it's implied. If you put the 1, that's fine.
What does that mean? What's the one like?
Wait, why would?
It means, that tells you how many times to multiply it by itself, so if it's 1, you only do it 1. If it was 2, it'd be x times x. If it was 3, it'd be x times x times x. It tells you how many
I'm just
times.
saying, how do you explain one? Because you would think one would be like 2. No, I know the answer, but I'm going how to explain it.
Because it tells you how many times to take the base and multiply it. So if it's an exponent of 1, it says only 1 time. So it's x.
0, could the answer be 0 though?
Well, we're actually going to get to a 0 exponent. If it's 0, what do you always it's 1. That's
I
exactly
know
right.
that, I'm just saying, should it maybe be 0?
Yeah.
Why would it not be 0?
Oh, man. Hey, give me that prop. Right.
2x squared over 3x.
All right, the 2 and the 3 can't simplify. There's an implied 1 here.
So
Right.
you would subtract by 1.
Right, so it would be 2x, that 3 is still down there. Yeah.
Because it's
Or 1 or 0.
So wait, why do you take away the x?
Yeah.
From the 3? Oh, because it's not
By the
2x.
way, it would be gone. Would be gone. Oh, I get that.
I have a question.
Not really, but like.
So something to the 0 power.
Wait, Jordan, what do you say now?
No, they're different. We're gonna get to that. We'll get to, one of the 7 properties is to the 0 power. What?
It's a 1, right? Anything is 0 power is 1.
I thought we were on the.
Y'all are jumping ahead. Wait, we'll get there. We'll get to 0 exponent.
Can we go to number 4?
Okay.
Hold on, wait.
Let me show you this before we go to number 4. What if I had, and by the way, let me preface it with this. Negative exponents are bad. Nothing is ever simplified when you keep a negative exponent in the answer. So if you're asked to simplify something, you got to get rid of all negative exponents, okay? So let me just start with that. Now let me show you this problem. Let's say I have x to the 3rd over x to the 10th.
Then it would become x to the negative 7.
Then
And then you do it in there.
And then you
exactly.
flip it in all
3 minus 10 would be negative 7, but because a negative exponent is not simplified, I would need to flip it and make it positive,
Yeah.
okay?
Wait, so we have to go?
Oh, I kind of.
All right,
This is still floating over, this is still negative.
all right, here we go, next one. What number are we on? Number 4. Power of a power. Power of a power. This means I have something that already has an exponent on it, and I am raising it to another exponent. Okay. Well, you add them when you're multiplying in the same base. This one, you multiply the exponents. So you have to keep straight which one multiplies, which ones add. This is a pretty easy one.
Are problems like this?
What if that was a negative 5?
Huh?
It would still.
Oh, yeah, you multiply and then you.
So, and here's the thing about properties of exponents. And I think this is why students struggle with them so much. There's not an order of operations with exponents whenever all we're doing is multiplying and dividing. Because each one holds the same value. So you can do, there might be 5 different ways to do a single problem. Because one of you might do product of powers and then apply the negative exponent, and somebody else might do the negative exponent first and then do the product of powers. It just doesn't matter. As long as every property you do is validated as you go, you can go in any order you want to. Does that make sense? All right. So, and the reason I said that was somebody said, what if this was -5? Well, I could do this one of 2 ways. I could multiply first and then flip, or I could flip and then multiply. I come back to the same thing either way I go with that.
I like my first ways.
Keep it simple. We need simple stuff. You look
I feel like that's unnecessary.
Wait, so can't we just change it to the thing? We don't do the X to the second.
You can do either way.
Why
I'll
can't
see
you
you on
put that
work,
on the
that's
bar?
somewhere.
You can go the left or to the right. You do.
Wait, are we gonna have a homework?
Well, I mean, I'm not taking it up, so, but on your quiz, you better show that.
Are we gonna have a homework quiz tomorrow?
All right,
Can we be able to use our homework on the quiz?
No.
Oh, that would be smart.
number 5.
I'm never doing homework at home.
What are we on? Power
I was at 7.
of a product.
First ball. I thought
No. It's just easier for me as I explain them to you to give you a title with them, but you don't have to know the name.
Is that number 1 quiz?
All right, no. This is power of a product. So this time I'm taking a product, which means I'm multiplying something together, and I'm raising it to a power. This is a very dangerous property, and listen carefully because this is where you will kind of get mixed up, all right? And not that you'll get mixed up on this, but whenever you go to do something else, that's where it'll mix you up. In this case, I can distribute this exponent.
Yeah,
And I stop because they're different bases. Now, I say this is dangerous because this is power of a product. Product is the key word. Product means I'm multiplying in the middle, right? If this looked this way, I cannot distribute that exponent. Does everyone hear me?
Why?
Because you're adding inside. This is a FOIL problem.
Couldn't you just, okay, is it always gonna be like the variables X and Y, or is it gonna be like a number?
It could be
Because
numbers.
if it's a number, can you just multiply and then?
You could.
And then,
But it's probably going to be something like 2x to the 5th raised to the something.
it's not gonna be like.
Right. They won't be the same base in there. If they are, then definitely simplify inside if you can.
No,
but-
you can't do that for subtraction either.
So you can't do it for subtraction, but, and I'm going to do a couple more examples with this, but I think 5 and 6 really go together. But you can do it. You can't do it for addition subtraction, but you can do it for multiplication and division.
So then the last one will be.
Power on 0?
Yeah.
This one flips the last one.
So, for instance, if I have x over y, and this time it's to the 3rd, yes, it goes to both. So it's x to the 3rd over y to the 3rd.
Well, I didn't do second.
You can't, I just said it does not equal x squared plus y squared. If you were to simplify that, you would have to do x plus y times x plus y.
Well, I didn't write any of that down.
I'm gonna go back. So this would be,
Let's just write that down.
you won't have, that's not the point of this section right here. We will get to those at the, well, actually the end of this section. But right now, as far as a property of exponents, that's not what this is.
Wait, but pull that out in the.
Wait, what?
If you FOIL that out, no, you'd end up with x squared
Plus XY.
plus 2xy, because there's 2 xy's. There's an xy here, And there's an xy here. It is, plus y squared.
Y squared.
It doesn't give you the same thing, but here, because remember, an exponent tells you how many times to write it, right? So if I had x times y times x times y, well, those parentheses just imply multiplication, and since I'm multiplying in here, this is the same thing as x times y times x times y. Now I can use, right, I can add the exponents. That's why it works. They all work hand in hand, and this is just another example of how maybe you didn't see that that distributes through and you did it that way. It's not wrong. And then again with the division.
So, the sum of the problem will be
You could if we get there. I don't know. I don't know yet. I'm still just working through the lesson. You'll stop worrying about what you're going to have to do for homework and worry about learning this, and then we'll talk about homework.
Well, we're good.
What?
We're good.
Yes. And then we're going to put them all together because that's when it really gets sticky. All right, number 7. 7, several of you have already guessed. It is the zero power property. And it says that anything except 0. Anything raised to the 0 power is 1.
What's a 6?
Okay? If you ever get a power of 0, you know it simplifies to 1. The base just can't be 0. 0 to the 0 is undefined.
Undefined.
Is that like, wait, isn't 0 divided by something undefined? Or no.
Something divided by 0 is undefined, correct. That makes an asymptote. We're going to talk about that too. Yeah.
I don't understand something.
No, 2x to the 0 power would be 2. This would be 2. This would be 1.
I didn't know
Wait,
what it
So
said.
it would be
I'm
like
having a little
the
fit.
x to the 0 power comes into 1 and it'd be 2 times 1 and it'd be 2.
Correct.
I just don't
Correct.
understand something.
0 power, what?
Can you give us another example?
All that work
Yeah.
to make all this and they can't define it?
I'm not responding because it's wrong.
Let me give you another example.
Undefined.
All right. Here's where we pull it all together.
Wait, all
This is
7
going to
of them?
be, you have to determine what properties you need to use when, how to use them, and when it's completely simplified. And the way you know that it's completely simplified is you don't see any other property that you can apply to the problem. At that point, it's simplified, okay? Everybody always says, how do you know when to stop? How do you know when to stop? When there's no more properties there, then you stop, okay? But you keep going until you can't go any further. So, for example, we'll start easy. 2a negative 2 times 3a cubed b squared times c negative 2.
Oh, I know how to do this.
Now, I will tell you that if you struggle with this, and I don't make you do this, but it may be helpful. Whenever I teach this in CP, I make them do this the first few times they work with exponents. Write the property out beside it. So you know that you're using valid properties every time. Okay? So if you need that, by all means do it. If you don't, go ahead with it. Now, I see several things here, and I hope several things pop out to you as soon as you look at this. What is the implied operation, first of all, between these parentheses? Multiplication. Is there anything in this entire problem other than multiplication going on here? That's the only thing happening, right? And do you agree that this is multiplication, this is multiplication, this is multiplication?
Yeah, you can't, the only thing you can combine is those.
So do you agree that I could just drop the exponents and be, the parentheses and,
Yeah,
be okay?
yeah.
All right. Dylan has already said combine the A's. Is that what everybody did first? Okay. That wouldn't have been my first step, but if that's your first step, that is A-okay. Y'all are a tough crowd.
That was pretty good.
2, all right, so negative 2 and 3 is 1, right?
You mean right.
Yeah, because it's negative 2.
Six days.
Oh, but see, y'all are doing something different. Y'all are doing, that's what I would have done first. I would have done 6 first. But y'all said do the A's. It's not wrong.
Wait, what? Well, how is it not?
I thought it was
Because she didn't
six
do that
A.
yet.
All right, well, don't, every time the A moves, the 2 doesn't move with it. That is just simply something we multiplied to it out
No, when
front.
you multiply 2a to the negative 2 and 3a to the third, it's gonna be
Wait, I
6a.
thought-
So you're doing 2 different things at one time. You're multiplying coefficients and you're combining exponents. And you're not wrong, you're just doing 2 properties in one. I just wanted to do 1 property at a time. My first thought here, my first thing would have been this.
So, does the 3 not have an
The 3 never had an A.
Oh,
The mom
yeah,
says
it's not.
do
Oh, and then you do A.
You can't, the reason I'm being such a stickler on this with y'all is you cannot look at them as one piece altogether. You have to look at them as their own. Would you move the A and the B together every time you did something with it here?
No.
No. So why are you moving the 2 or the 3 with it every time you do something with it? They're separate.
I mean, I get what you're saying now.
Confusing because they have the same letter.
I think I got it.
You're not wrong in what you're doing, but I'm really harping on this because this is where students mess up. They think that if they move the A, they have to move the coefficient that's with the A, and that's just not true every time.
So you do the coefficient and then you do.
You can, yeah. All right, where are you confused? I've done 2 things right now. I multiplied the 2 and the 3, and I added the exponents on A.
At first, I did what Dylan did when it was like, I did 6A
You skipped a step.
1. Wait,
That's what we have.
I know, but like, where did the 3 go? I mean, no. I'm just kidding. Just forget it.
C negative 2, we have to change that.
C positive 2.
We will. That's another step there, yeah.
Okay, so when we wrote down product of power, like we did one, it was like 2x4 times 3x2. So why can't we do that? Why is that not like one thing?
Product of, what are you
Like,
saying?
because you said for the first step,
Mm-hmm.
we can't combine like 3a negative 2.
Well, it's not that you're not combining them. I was just showing you that
I like doing this.
Like, can we not
Are you
just
just
do
saying it doesn't always
6a?
work?
it doesn't always follow it. If you're dividing and then sometimes you won't need, it doesn't always, what if this was 2a negative 2 and 3b 3?
And then you wouldn't do that. But like,
But
why wouldn't it just be 6a
It
the
is.
first?
It is. That's what we have.
Oh, wait.
But we did a step before
Just
that.
want you to think of it.
I want you to see the separate steps in
Okay,
it.
wait, Miss, if you had 2a to the negative, okay, that one that you just wrote,
Mhm.
would you multiply the 2 and 3 still? Because it's its own thing?
Yes.
So it would be 6, and then whatever.
Mm-hmm. Yeah. If this, and don't write this down, and if this C right here had a 2 on it,
It'd be 2
this would
times.
be 12A B2 C negative 2. Because I'm still multiplying the coefficients.
wait, why would you multiply the coefficient because they don't have the same base?
That doesn't, they do, you're not, that's why I wanted to show it to you that way. You're not adding here. This is not like terms that you're looking for. I don't know what
Wait, I
just
thought we
happened.
were combining like that right there.
Nope. Combining like terms is an addition subtraction thing. It's not a multiply. You're thinking combining, you're looking for like bases to combine, but we're not combining like terms. All this is technically one term. Terms are separated by plus and minuses.
You're saying that I can multiply all the coefficients first?
Yes.
That's what I'm saying.
And then put the letters after the
Yes.
one percent?
So,
That was a lot better.
So you- But how would that not combine?
No, we're not done yet.
I don't understand why it's not combining like terms. If you like find all the coefficients. and then-
Combining like terms is whenever you look at ones that have the same base and the same exponent and you combine their coefficients.
So you're just combining, the
No, you're doing,
at least that's wrong.
That is combining like terms.
Oh.
That would be 7x to the third. The base
Oh.
stays the same, the exponent stays the same, the coefficient's the only thing that combines.
Why is it-
We're not combining like terms here, because we only have one term. This is two terms because it's separated by a plus. This is one term.
Oh, weird. But
Yes.
It's not done yet. You
No,
gotta-
we're not done yet. We're not done
You
yet.
gotta flip the C.
Yes.
Flip that.
The order doesn't matter. Multiplication is commutative. You could put it wherever.
Agreed.
The question was, why does the 6 go in front of the A and not in front of the B? And the answer is it doesn't matter. Multiplication is commutative, and since all I am doing here is multiplying, I could write this in any order I wanted to.
It's not even close to the B. Why?
Well, she's just saying, could you put it in front? Like, why does it matter? Why does it have to be at the front? So it doesn't matter. All right. Yeah, it's neat at the front. All right, so I mean, but at the end, you'd only have one set instead of 3. All right, C to the negative 2 here flips down to the bottom, so I end up with CAB squared over C squared.
You said C is.
Oh, I'm sorry, I meant 6. I meant 6. They sound alike. So looking at this, how do I know when I'm done? Are all the coefficients simplified? Yes, meaning 6. There's nothing in the bottom that would reduce down with that.
Division thing now.
And looking at the division thing, I don't even see any more same bases. There's not another property that I could apply here, so I am done.
So you only
Final
subtract,
answer.
you only subtract exponents from the
Same base, has to be the same base.
I'll take it.
word.
All right,
That's not too bad. It's not too bad. I need another.
I thought, at
we're gonna
first
do a
I
couple
said
more.
6A times B to the second times 1
That's what I
That's
was
what I was
over
thinking we were
two.
doing.
I mean,
A 1
over
over
C.
C to the second.
That's what I was.
That's what I
You
was
could have done that, and then you would
should've
just
done the
combine
beginning.
it if it's 1 over C, and then you multiply across.
Yeah, I'm just gonna do it how you did it. because-
Well, I just ate at Chick-fil-A. Should've done that day.
Yeah, you're probably right.
That's
You
a
could've done it
cue.
in cold.
Shh, guys. Don't blurt it out. Okay. This is a super duper easy one. There is only one property here to start with. There's only one thing that you can do.
I wrote R instead of R4.
As you look at this, do you notice the same bases? Yes. Okay, so look at what has the same bases because I am dividing, which looks like a subtraction sign, right? There's your little, what is it, a mnemonic? No, it's not a mnemonic device. When something looks like something that, anyway, there's your little stupid little trick that helps you remember. It looks like a subtraction sign, which clues you into subtracting. No, I'm pretty sure that's not what it is. All right.
Yo, it is up on my phone.
When you subtract, make yourself a note. When you subtract, even if you get a negative value, it always stays in the numerator, okay? You can flip it later, but when you subtract, you keep it up top. In other words, 2 minus 7 is negative 5, right? It's not negative 5 in the bottom, it's negative 5 in the top. 4 minus 3 is 1.
Do I have the ones that
And then flip.
didn't ask me?
Or,
Do you see the two properties that you did here?
yes.
Is there any other property you can apply?
No.
No. Yes.
Could you get ones on the left and
No, that's fine. If you need the one on the R. All right, let's kick it up a little bit.
First one was.
I like this picture. Yeah, I like just keep it like this when the chapter comes. Have you looked at it yet? Yeah.
Probably today.
Are we gonna watch them before 3 o'clock?
Yeah,
I haven't actually seen them. We're not gonna watch them as a class?
All right,
That's something I gotta go.
looking at this, be very, very, very careful, okay? And make sure you look out first for pluses or minuses.
I see a
Alright.
minus.
I see it.
Like addition or subtraction, plus or minus. So,
Well, never mind.
okay? So, yeah.
Did you multiply 3 for both?
Yes. Okay, so not just both, but all three.
Yeah.
Do you see the three different parts? This is why I really, really, really was harping on the coefficient separate, the coefficient separate, the coefficient separate. It is its own base and it is completely separate. So whenever you do distribute through here, and because I'm multiplying and dividing, remember that's when I can distribute the exponent.
Do you want us to?
It's gonna go to every one.
Do you want us to simplify by actually doing the negative 2 to the third? Like,
You can, it's up to you. I'm okay either way.
oh,
Now,
Can't you just go ahead and simplify right off?
you're doing, remember, I'm just trying to show you every single step so you see each individual property.
I didn't do that. Did you show that?
I'm okay if you go ahead and multiply them, that's okay. But I really wanted you to see that it's power of a power here is what we're fixing to do.
Yeah.
This is actually, so taking it in here, that's power of a product, power of a quotient, and now power of a power.
Yeah.
When you solve negative 2 to the third, it will be positive 2 to the third.
Be negative.
It'd be negative 6.
It's not parentheses.
Yeah, it's negative 6.
Technically, this is a fraction. It used to
Or
divide
negative
by, like,
Look at it's like negative.
Say that one more time.
this is a fraction.
Like, I thought
No,
those
no,
always.
it's gonna be A over 12, and B over.
They do when the exponent's even.
No, you can't do that, you can't do that. Do you want to hear the question? Can we simplify the exponent here, the 12 and the 6, and make it 2 over 1, and we can't do that on the exponents that way. They have different bases, so once you have separate bases everywhere and no other properties to apply, you stop.
Wait, on our calculators, do we still put the actual numbers with if it's like a negative number with the exponent, do we put it in parentheses? Because I don't know if it's too positive or
The
not.
easiest way to remember is if it's an even exponent, it's going to always be positive. If it's an odd exponent, it carries the same sign.
Where is-
So it doesn't matter if it's a word.
No, the coefficient can be negative, just not the exponent.
Is that what I do?
What do I do?
Wait, so if you had a negative coefficient and it was odd, you flip it and then you do it?
Odd.
That just has to do with the sign of the number.
Yeah, if you had like -2 to the negative like fifth, you would flip the sign
Mhm.
and then you would go from there. That would still be negative.
Still be a negative answer, yes. Yes. All right, let's see how good you are.
Well, no. Yeah, I have 5 pages. Wait, so you're but like the answer in total is going to be a negative because it's a negative coefficient and it's an odd one. It's so intellectual.
Whoa there, Miss McGee.
That kind of
This one,
Wow.
no.
That took you a minute,
nervous
right?
laugh.
This is number 50 from your homework.
Can you help me do it, please?
1 through 50 all.
No, I'm
Yes.
Can you ignore the parentheses first?
On this one, you can because you're just multiplying in the top.
Okay. You can just ignore her.
So you can take the parentheses away.
Sure, because be careful, make sure when you take them away, you're taking them away and you're not doing any other operation. That's the only reason that I can take them away there.
So can you divide negative 12 by 36?
Huh?
Can you divide negative 12 by 36?
You can simplify this since there are coefficients in front. That can be simplified down to what? How does it simplify?
Negative. What?
I don't think I was
12 over 36 is a fraction reduces to what?
So you just add in like the instead.
You know what, you're right. I don't know what.
Look at the numerator.
Wait, but if it was 36 over negative 12, would it give a negative 3 on the top?
Yeah, it doesn't really matter which one's negative.
Wait, Miss Vicky.
Because by definition, a negative divided by a positive is a negative, or a positive divided by a negative is a negative.
That'll be the quotient one, right? The n, the 7 minus.
No, you gotta multiply first on the top.
Okay, but you don't have to.
But I want to.
Okay, well, you can, but if you do that, yes, it always stays up top. So I'm actually, and let me do it, you're not wrong, Dylan, but let me just show you this way too. So Jordan asked, could you go ahead and subtract these? And you can, since they're the same base, and it stays up top. So 7 minus 6 is 1.
It always stays up top?
Wait.
And 5 minus 7 is negative 2.
See, that's why.
But I haven't done anything with these yet, so they're still there.
They're just chilling right there.
Okay.
The,
Now, if you combine the numerator first, and that's probably the way I would have gone with it, but I'd really like for you to see that there's not a right or wrong way here. If you combine the numerator top at the top first, then you could subtract the exponents and you can move on. But we subtracted first, and now we can combine the exponents up here. So we have negative. I've got 1 n and 2 n's, which gives me how many n's?
3.
Why did the subtraction signs go in? No, the n to minus. The board.
Alright.
So I'm sure that you will know why you say board. Yeah.
But all your gives
Are you?
Say again.
What if I went ahead and put these three on the bottom?
That's fine. You can do that next. That's fine.
So then what do I do from there?
All right, hold on. So at this point, you put this on the bottom? Okay.
That's what I would do.
Okay, we'll do it that way. That's fine.
Wait.
Listen, remember, guys, y'all are getting caught up, and I told you there's probably 6 or 7 different ways to do this one problem.
Oh, then you just subtract 2 from 4.
You're doing the same thing. All right, so now I'm going to do negative 1 n, and you said put that p negative 2 on the bottom.
No, it's still.
Well, this n1 is still here. Okay. Now what did you do?
You just subtract.
All right, so Dylan says subtract here.
Yeah.
You put that as parentheses on the top?
Yes. 4 minus 2 is 2. Am I done?
No.
Why?
Combine like terms.
So maybe you did this a different way,
What if I
but
were
you
negative
should have come back to the exact same answer.
I did. What if I were negative 1?
Yeah, let's do one more.
Why did I bring? Shh, shh.